Alright everyone, this is the Gabulator here with another tutoring video. So this is something that I've helped out people with before. Sometimes in math you're given a problem, whether it's a word problem or a system of equations. Basically different equations with multiple variables, some different letters. So it's usually X or Y. It can be something like A and B or M and N or P and Q. They love to use letters next to each other in the alphabet. Either way, you will either see in your homework or on a test, it will say solve with elimination and or substitution. So I'm here to show you both because sometimes they will tell you to solve it specifically one way or the other way. And a lot of people feel more comfortable doing it one way over the other, but it's good to know both because here's the beauty of it. Both of them get you the same answer. So it's useful to know both so that when you're given the option to solve it however way you like, you can solve it either with elimination or substitution. But when they tell you on homework or a quiz or a test to solve it specifically with one way versus another, you'll be able to do it. If you hear crunching in the background, that's my dog. She's chewing her bone. I might show you guys at the end of the video. Or in a short at the end, who knows. Alright, now the reason why on a test they would ask you to do one way specifically, it would say, for example, solve the system of equations with elimination method or with substitution method. It's not necessarily they're looking for the answer because they know you can get the same answer using either way, but they want to see if you know how to do it one way or the other. Alright, so without further ado, I'm going to start with elimination, and then I'm going to go to substitution, alright? And you'll see at the bottom, we'll end up with the same answer. Alright, now personally, I like elimination better, but a lot of people tend to prefer substitution. Just depends on the way your brain works. Alright, so remember my step 1 from previous videos? Always write down your problem. I've already pre-written down the problems here on either side and divided my graph paper a little bit so it's easy to write on. Alright, now elimination, basically the whole process is just treating it like a big giant addition problem. So I'm going to write it down again over here so I can have a left side and a right side. So I've got 2x plus y equals 6, and 6x plus 2y equals 4. Alright, now we're going to treat this like a giant addition problem. Okay? So I'll draw a line underneath it. I've got a plus sign. All right, now with my problem, the way it is right now, we're looking to see if we can eliminate, like knock off, cancel out any of our letters. We don't worry about the numbers here. We're worried about X or Y because we can't work with both at the same time. We need to get rid of at least one of them. So right now we've got 2x and 6x. They don't match. We've got a positive, that's an invisible 1, y, and a positive 2y. Those don't match either. So what we have to do is we have to manipulate one or both of these equations so we can eliminate a variable. Now here's another thing where people get confused. You can pick either x or y. You can do whichever one you want. You don't have to do X all the time. You don't have to do Y all the time. It's whichever one you want. And the way I tell people, do whichever one is easiest. All right? So the easiest way to do this, if you look here, we've got a positive 1y and a positive 2y. Now the easiest way to eliminate one of these is to eliminate the y. Y, pun not intended, is I can just multiply my top equation throughout with a negative 2, and that'll eliminate. How? You'll see. I'm going to distribute that negative 2 and multiply it to every term. So I've got negative 2 times 2x, so that gives us a negative 4x. Then we've got negative 2 times a positive y, which gives us negative 2y. And then we've got negative 2 times positive 6. That gives us a negative 12. Alright, everyone follow what we just did there? Negative 2 times 2x, negative 2 times y, and negative 2 times 6 gets us negative 4x minus 2y equals negative 12. Alright, now this bottom equation, we didn't change at all. So we're just going to rewrite it again. We've got 6x plus 2y equals 4. Alright, I'm going to draw my line my addition sign. All right, so do you see what I did there? Just by manipulating one equation, I was able to get these two to cancel. Because if you look here, if we treat it like an addition problem, works straight down, negative 4x plus 6x will give us 2x. Negative 2y plus 2y gets us 0. They cancel. They disappear. And then we've got negative 12 plus 4, which gives us a negative 8. So our new equation is 2x equals negative 8, because those y's just disappeared. Now, if it was easier to get rid of the x's, I would have done that. Technically, I could have. I saw an easy opening here with the y's just by multiplying by negative 2. But in reality, I could have multiplied by a negative 3 as well and canceled out the x's. Because if you do negative 3 times 2, that'll get you a negative 6, and that would have canceled out the x's. So there's a lot of variables here, people. You can do it whichever way you want. There's no right or wrong way, as long as you do the math right, okay? As long as you get your multiples, your multiplication, your addition, subtraction right, you can do whichever way you're more comfortable with, all right? Whichever way makes your brain click. That's all we're looking for here. Now, we haven't quite found x yet. So we just got to divide by 2 to get the x by itself. Not a negative. See, even tutors do it wrong sometimes. I was about to divide by negative 2, but it's actually a positive 2 that we've got. So if we do negative 8 divided by a positive 2, our x, remember to circle your answers, our x is a negative 4. Now, in problems like these where our answer is going to end up being a point, like on a graph, so with an x comma y format, I usually put it up here at the top so I don't forget that I've written it. So we know that our x is going to be negative 4, right? So we've got x comma y, right? Now you're like, okay, so we did that much. Now how do we find the y? Now at this point, it's going to be the same in either problem. The only way to find your other one is to go back to a previous equation, plug that x in, and then find your y. So let's go back up to the top. Now at this point, I'll tell people again, you can put your x into both equations because they'll both give you the same answer for y. That's the beauty of it. But you can pick whichever one you want. And I have had times where I have given people the choice that I'm tutoring, like, okay, you go ahead and pick the equation, we'll do it whichever way you want. Now I've already got an equation in my head, I'm like, okay, I know this one will work good for me. That one looks easy enough to me, but the person I'm tutoring picks the other one. And I'm like, okay, let's roll with it. Because guess what? They both get you the same answer. Hey, baby. Sorry, dog time. All right, so if we go back, I'm going to pick this top equation because it's got a fewer amount of numbers, and that's what makes sense to me. So we're going to do 2x plus y equals 6, okay? Now I'm going to rewrite my x as a negative 4 because we're plugging our answer back in so we can find our y, all right? So we've got 2 times negative 4 because that's what 2x means. It's always 2 times the number, or 2 times the letter that eventually is a number. All right, so 2 times negative 4 gives us negative 8 plus y equals 6. Now to get the y by itself, we have to add the 8 to both sides. So 6 plus 8 is 14. So our x is negative 4 and our y is 14. Okay, so that is our answer. Our answer is negative 4 comma 14. That is the answer to this pair of equations with the elimination method. Okay, because we eliminated one of our variables in basically a giant addition problem. All right, now we know this is the answer, but now we're going to do it in substitution style just to show how to do it and to prove that we get the same answer no matter what we do. All right. Okay, so we're going to write down our problem again, like we always do. So you've got 2x plus y equals 6, and we've got 6x plus 2y equals 4. All right, now in this case, we're going to need to pick an equation again, okay? But in this case, what we're going to do is we're going to write one equation and rewrite it, flip it around so that it says either x equals something or y equals something, because we're going to take that and plug it into the other equation. All right, it'll make more sense when I do it. All right, so just for easy's sake, since we did y in this first problem, just to stick with consistency, we're going to pick y in this problem as well. All right, so I'm going to take my first equation, 2x plus y equals 6. All right, now I want to get y by itself, okay? All we're doing here is we're getting a letter, which is a variable, by itself. Okay, so I'm going to pick the y simply because it's got no number attached to it. Okay, it doesn't have any number attached to it, so that saves me a step. If there was a number attached to all these variables, then no matter which one you picked, you'd have to divide out that number at the end. All right, but this one just has a 1 in front of it, so that saves me trouble. So I'm going to subtract this 2x and move it to the other side. So we're going to end up with y equals negative 2x plus 6. Now I've noticed a lot of people will write this equation also as 6 minus 2x because that makes more sense to their brains. Because they're like, well, the 6 was already here and then negative 2x goes behind it. These are the same thing. It's just you'll find in a lot of textbooks and in a lot of online math courses as well, they will not accept this form as the answer. They want it in proper order, which basically just means if it's got a letter and connected to it, put it in front of the number. It doesn't matter in reality. The computer will just want it a specific way, so save yourself some headache and just try to get into the habit of putting letters first before the regular numbers, okay? So we've got y equals negative 2x plus 6. And I'm going to take that and I'm going to plug it into this second equation. How? I'll show you. So again, I'm going to write it down. I've got 6x plus 2y equals 4. Okay, now this equation over here is saying this phrase, negative 2x plus 6, is y. So anywhere there's a y in this equation, I'm going to replace it with this phrase. Okay, it's kind of like secret agents, or like your name. Okay, so like for example, if you ever been taking roll call or whatever, and someone goes, last name, first name, and then you're like, hey, that's me, but I usually go by insert nickname here. That's the same thing we're doing here. This is your full name, but we're going to put your nickname in here, okay? So we've got 6x plus 2y, in parentheses, negative 2x plus 6 equals 4. Now I'm going to pause here for a second because it's at this point that a lot of people go, wait, what'd you do? It's like, all I did, there's a y here connected to a positive 2. All I did was replace it with our negative 2x plus 6. That's it. I didn't change anything else. The 4 is still the same. The 6x is still the same. The 2 is still there. But instead of 2 times y, it is now 2 times the phrase negative 2x plus 6. All right? Now, with any good parentheses, we got to do some distribution, okay? So we got to distribute that 2, okay? So we do 6x plus 2 times negative 2x gives us a negative 4x, okay? And then 2 times 6 gives us 12, all equal to 4. Now I'm going to rewrite it again because I've got 2 different signs here and that's going to be confusing. So I'm going to do 6x minus 4x plus 12 equals 4. Okay, now we're going to simplify. We're going to combine numbers with numbers and letters with letters. Okay, so we've got 6x minus 4x. Well, simplify that. That's just going to give us 2x plus 12 equals 4. Okay, now let's move this number over here. There's a number on this side, so let's move this 12 over here to this other side. Now, sometimes I've noticed people like to move it from this side over to here and then move the whole thing back over. That, to me, sometimes sounds like it could be confusing because you're doing a lot of extra movement. But if that's how your brain works, and if you do it right, go for it. Just don't forget to change your signs when you're flipping around an equation, okay? Anytime you move a number from one side of the equal sign to the other, you have to change the sign. It's a must. It's like driving from America. If there was a bridge connecting America to Europe, you always have to switch which lane you're driving from, and that would be a huge mess. That bridge would be full of so many accidents. Okay, you drive on the right side in America, you have to drive on the left side in Europe. If you're on one side of the equation and you're positive, you have to turn into a negative on the other side. If you're a negative on one side and you go to the other side, you have to become positive. You have to change the sign. All right? So we're going to do a negative 12. Move it over there. Now we've got 2x equals 4 minus 12 gives us a negative 8. Okay? Almost done. Now we divide both sides by 2 to get that x by itself. And our x equals a negative 4. Doesn't that look familiar? I would think so. Okay, now that we know that x is a negative 4, this is where the easy part of substitution is for me. Now that we know x is the negative 4 and we still need our y, we've got a handy little equation right up here in the corner that already is set up for y equals. Okay, so we're just going to write it again. Y equals negative 2x plus 6, and we're going to substitute our x in there. So we've got negative 2x times a negative 4 plus 6. So negative 2 times a negative 4 gives us a positive 8 plus 6. Y equals 8 plus 6, so y is 14. Boom. Same answer, different methods. Both work, both are interchangeable. Now you know how to do either one, okay? I personally prefer this method. Some people prefer this method, okay? Just depends on how your brain works, all right? Hope this was helpful.